answers and let me know the time. Let's start it. Okay, I'm gonna hide this as well. Okay, so find the solution or solutions to the system of nonlinear equations given by, in this system, we have two equations. The first equation, y equals x plus 2, is linear. The equation represents a straight line, and the equation is in the slope-intercept form. Y equals mx plus b is the slope-intercept form, right? Very basic. So you can see the first equation represents a straight line with a slope 1, positive. So the line goes up, and the y-intercept 0, 2. And in the graph, you can see this is the y-intercept. Oh, the graph is not very accurate. This is supposed to be 0, 2. The second equation in the system is not linear. Is not linear because the exponent on the shoulder of x is a second power, is 2. And the second equation, in fact, represents a parabola. So we call this system as nonlinear system or quadratic system. So how do we solve a nonlinear system? The basic tools are the same. We have two tools or two methods, substitution method and addition method. Every time before you solve a system, do not rush. Observe the two equations. Find an efficient way. Find an efficient way to adopt the correct tool to eliminate one of the variables. So in this question, let me copy the two equations. For this specific system, first equation y equals x plus 2. I'm going to label number 1. Second equation y equals negative x squared plus 2. Look at the connection between the two equations. The two equations have identical left side. Both the left side of the equations are y, right? And on the right side, they have two terms. The first equation is x plus 2, has a 2 constant term. Second equation has also two terms. The first term is negative x squared. The second term is always also 2. So I'm thinking, what if we use equation 1 to minus equation 2? What do you think? What if we use equation 1 to minus equation 2? Do you think the left side is going to become 0? And the right side, do you think we can get rid of the constant 2? So that's the idea, all right, for this specific system. So we're going to apply addition method. Subtraction is a special addition. What are we going to do is, firstly, we multiply equation 2 by negative 1, all right? Then the equation 2 will become to negative y equals positive x squared minus 2. I'm going to label this equation as 3. And I put the equation 3 with equation 1, which is y equals x plus 2. Equation 3 is a modification of equation 2. We get equation 3 by multiplying equation 2, all the three terms, by negative 1. So positive y become negative y. Negative x squared become positive x squared. Positive 2 become negative 2. And then we are going to apply addition method. Add 1 and 3 together. Add the two equations together. Let's see what will happen. What will happen? Negative y, positive y cancel each other, 0. On the right side, negative 2, positive 2 cancel, 0. And those two terms will not be eliminated, okay? Yeah, not everything disappear. y disappear, 2 disappear, but we still have x squared plus x on the right side, okay? For convenience, I'm going to switch the two sides of the equation. We have x squared plus x equals 0, right? And then we can solve this equation. Earlier, through the addition method, we eliminated the variable y, right? By adding equation 1 and equation 3. That actually was the idea, using equation 1 to minus equation 2, okay? Same thing. We got rid of variable y. This equation now only has variable x. Let's solve this variable. Let's solve this equation for variable x. Right hand side is already 0. Right side is 0. Left side is a binomial. This binomial is easy to be factored. We factor x out. Inside the parentheses, we have x plus 1. All right. I'm going to rewrite the left side as this way. Right side is 0. And the left side, we have the first parenthesis is x minus 0. Second parenthesis is x plus 1. I wrote x as x minus 0. Same thing. And x plus 1, I write the plus 1 as in red. Then the solution of the equation is the opposite of the numbers in red. The opposite of 0 is 0, right? The opposite of positive 1 is negative 1. So those are the two solutions. The two solutions of the equation x squared plus x equals 0. But we're not done yet. Our goal is to solve the system. The solution or solutions of the system must be ordered pairs, with two components. Now we only have the values for the first component. We only have the values for x, right? We need to find the value for y. So when x equals 0, as x equals 0, we are going to plug x equals 0 into one of the original equation. Equation 1 obviously is easier, right? Simpler. So we're going to plug x equals 0 into equation 1. Equation 1 says y equals x plus 2. So we have a y equals 0 plus 2, which is 2. That means when x assume a value of 0, the corresponding y value is 2. We have the first solution 0, 2. We have the first solution 0, 2. As x equals, let me find a space. How about here? As x equals -1, and we plug x equals -1 into equation 1. Equation 1 is y equals x plus 2. X is -1. Replace x with -1. -1 plus 2 is a +1. So y equals a +1. That means when variable x assume value -1, the corresponding y value is a +1. And we found another solution. So this is the first solution, ordered pair. This is another solution, another ordered pair. And it is, match what we see in a graph. This red point is the y-intercept of the straight line, right? Equation 1. It's also the y-intercept of the parabola represented by the second equation system. And the two graphs happen cross at the y-intercept. So 0, 2 is a solution. Graphically speaking, the straight line represents equation 1. The parabola represents the equation 2 in the system. Wherever the two graphs cross, okay, wherever the points the two graphs cross or intersect, those points are solutions of the system. We have two because the straight line and the parabola intersect at the 2 points. One is the y-intercept, the other is this one. And the scale is a little bit weird. It's supposed to be -1, 1, all right? So that's how do we solve a system, nonlinear system. The two basic tools are the same tools, still work in this type of a problem, either substitution method or addition method. the way to solve a system is not unique. Just practice and use whatever the method you feel comfortable. Another question, let's do this one. Use the elimination method. Here it says elimination method actually means substitution method or addition method to solve the system. In this system, we have two equations as well. Equation one actually is a hyperbola. Equation 2 is a ellipse, you know? Yeah, but you don't have to know this, okay? In your Lumen, you can use the graphing calculator to figure out what's the graph for each equation. And I can tell that equation 1 represents a hyperbola. Equation 2 actually is an ellipse, and we need to solve this equation. Let's see how do we solve this equation using algebraic method, either substitution or addition. Let me observe the left side of the two equations. So we have 3x squared minus y squared equals 11, and we have x squared plus 4y squared equals 8. Okay, so this is what I'm going to do. I'm going to use addition method. Yeah, I actually like addition method a lot. I'm going to multiply equation 1 by 4. Let's see what we have after this. Equation 1, every single term in the equation 1 multiplied by 4. 3x squared multiplied by 4, 12x squared. Negative y squared multiplied by 4, negative 4y squared. On the right side, 11 times 4, 44. It always is good to double check each step. Equation 3 is a modification of equation 1. They represent the same equation, but appearance-wise look different. We got a number 3. We got equation 3 by multiplying equation 1 by number 4. 3 becomes 12. Negative 1 becomes negative 4. 11 becomes 44. And then I'm going to put equation 3 with equation 2. Equation 2 is x squared plus 4y squared equals 8. This is equation 2. And you can see the reason I process the system this way, right? Because when you look at equation 3 and equation 2, y squared have opposite coefficients. So if we add 3 and 2 together, let's see what we have. Those two would be cancelled, right? Negative 4y squared, positive 4y squared, they would add up to 0. They are opposites, so they cancel each other. And x squared, 12x squared plus 1x squared, that gives 13x squared. On the right side, 44 plus 8, we have 52. And then we divide each side by 13. After we eliminate variable y, we only have variable x left in the equation. Then we can just solve the equation for x. 13 cancel 13. X squared equals 52 over 13. That is 4. And when x squared equals 4, remember our square root property. If x squared equals a, then x equals plus minus root a. We apply the square root property here. We have x equals plus minus root 4, which is plus minus 2. All right, so we have two solutions, two values for variable x. We have two values for variable x. As variable x assume 2 positive, we are going to plug x equals 2 into one of the original equation in the system. Let's see which one has a smaller coefficients. I think we can try number 2. Equation 2. Equation 2 has equation 2 actually. Yeah, let's do equation 2. At least we avoid the negative sign. Equation 2 is x squared plus 4y squared equals 8. When x equals 2, x squared is 4. 2 squared is 4. And plus 4y squared equals 8. And we can subtract 4 from each side. And we have 4y squared on the left side. Right side, 8 minus 4 is 4. And divide each side by 4. We have y squared equals 1. When y squared equals 1, we apply the square root property. Again, we have y equals plus minus 1. Right? Yeah, do not forget, negative 1 also satisfies the equation. So that means as x assume value 2, we have 2 corresponding y value. Okay, we have 2 corresponding y value. One is a positive 1, the other is a negative 1. That means we have 2 solutions now. So far, we have 2 comma 1, and we have 2 comma negative 1. Because when x equals 2, we have 2 corresponding y values, 2 comma 1 and 2 comma negative 1. And by the way, nobody say this is a function or this is a function, okay? Do not confuse this with for each single husband, there's only corresponding one wife. We are not talking about function. We are not talking about function. We are solving system of 2 nonlinear equations. So now, so far, we have 2 solutions found. And we also we have to continue because x can also assume a value of -2, right? I'm going to use find some space. As x equals -2, then we're gonna plug x equals -2 into equation 2. Equation 2 again is x squared plus 4y squared equals 8. We solve the equation for y by plugging x equals -2. When x is -2, x squared is the square of -2, which is positive 4. Okay, be very careful. Perfect square is never equal to negative. So x squared is still positive 4. And you see something very familiar, right? We just did exactly the same thing. Because 2 or -2, they all give x squared equals 4. And they cancel, we have a 4y squared equals 4. And we have a y squared equals 1, y equals plus minus 1. So when x equals -2, we have 2 corresponding y value. Y could be positive 1 or -1. So we got another 2 solutions. In total, we have 4 solutions, right? In total, we have 4 solutions. The result is consistent with the requirement of the problem. It says here, the 4 solutions of the system are, and negative a comma negative b, negative a comma b, a comma negative b, and a comma b. And they want you to enter value of a and the value of b. Okay? Yeah, let's see. Let me write the 4 solutions right here in blue. We got the 4 solutions. We have 2 comma 1. We have 2 comma -1. We have -2 comma 1. We have -2 comma -1. And compare the 4 solutions. Let's use the pink. Compare the 4 solutions with the format provided by the problem. And can you tell the values for A and B? What is A, what is B? It's interesting, the question's not directly asking you to enter the 4 solutions, right? You have to follow the instruction. And what's A? A actually is the absolute value of the first component of the solutions. A is the absolute value of the first components of the 4 solutions. Michael, what's the value of A supposed to be? Are you there?
Yeah.
Yeah, what is the value of A?
-2 or +2?
A +2, actually. Oh, actually, -2 works as well. Let's see, but it says look at it here. What it says here.
Oh, okay, 2.
Yeah, exactly. Very good. Perfect. Max. And what's the value of B?
1.
Perfect. Yeah. We must follow the instruction. The system requires you to do a certain thing or enter the result at a certain format, in a certain format. We have to do so. Otherwise, the system mark your problem, your result is incorrect, right? We have to follow the instruction. All right, that's the last problem of this unit. We spent 24 minutes on that. Let's go to Lumen. Let's go to Lumen. I need a stop share this one and share the website. Lumen. Here. This is the starfish. Let me know. Do you see Lumen?
Yes.
Okay, awesome. Homework 2.6. And graphing calculator actually making me don't want to really teach this part anymore, because you can just easily use the graphing calculator to find the solutions. For example, this problem. Calculator, all you need to do is to enter the 4 equations into the calculator. The first one is an equation, right? Expression is y equals negative 4x plus 3. And then add another equation, which is y equals negative x squared, x shift 6, 2, so x squared, right? And then plus 3. And so I have the 2 equations entered, and look at what happened in the graph. And you can see where the 2 graphs intersect, right? One solution is going to be here, 0, 3. The other solution is going to be here. When you point it to the point, they even give you the coordinates, 4, negative 13. Okay, let's see, 0, 3, 4, negative 13. Let's check the result. 0, 3, 4, negative 13. Use comma to separate the 2 solutions. So I would say, I of course cannot prevent you from using the graphing calculator, right? But the previous section 2.5, solve linear system, I would really recommend you do not use the calculator, because the purpose is to grasp the 2 methods, substitution method and addition method. All right, let's try one more. Let's try this one. This one is actually the same with our example. Let's try a different. This is a circle and a straight line. Now let's try this one. This is a circle and a hyperbola. Okay, let's use a calculator. We enter equation or expression x squared, x shift 6, 2, x squared. Okay. Second power x squared plus y squared. I don't know if this works. Let's try. Equals 5, right? It's a circle centered at the origin with radius √5, not 5, √5. And then you enter another equation, x squared minus y squared equals 1. It's a hyperbola, right? 2 branches. And you can see the solutions from the graph. If you point it here, okay, this time it doesn't really give us the, oh, it does. Oh, I got it. So the solutions are not, the coordinates of the solutions are not convenient anymore. Okay, it's not like rational. It's possible it's irrational, like root 2 or root 5, right? And let's see the answer here. Yeah, okay, good. You would have to know the 2 methods, okay? Sometimes the graphing calculator helps you. Sometimes the graphing calculator cannot help you. It will give you a decimal, but the system requires you to enter the exact solution. You see that? With exact coordinates. But you can use the graphing calculator to assist you. At least from the graph, we know there are 4 solutions, right? And you won't miss any. You're going to find out the 4 solutions. And then the 4 solutions are very symmetric, as you can see. It's symmetric with respect to the origin. So are we good? How about let's solve one more. If there is more than one solution, enter as a list of ordered pairs example. Okay, let's solve this as the last problem. Because this problem is going to use substitution method. Okay. Going to start a new page. Insert page break. Put it here. All right. Let me stop share the website and then reshare my note. My note, this one. All right. So this problem, this system, we are going to apply substitution method. Only 2 methods, either substitution method or addition method. Okay, this one is very convenient if we apply substitution method because in equation 1, variable y is already in terms of x. Okay, so we can use x plus 4 to substitute y in equation 2. This is equation 2. Then we can get rid of variable y. All right. So since in equation 1, y equals x plus 4, variable y is already given in terms of x, then substitution method would apply to solve the system. We use x plus 4 to substitute y in equation 2. Because y and x plus 4 is the same, right? In the middle, we have equal sign. It's just like if you have 2 $10 bill, right? If you have 2 $10 bill, you can substitute a $20 bill for the 2 $10 bill because they are equal, right? So the same idea. And the purpose is to eliminate variable y. Okay, equation 2 is x squared plus y squared equals 10. And then when we plug in, when we substitute x plus 4 for variable y, we copy everything in equation 2 except variable y. So we see x squared, we copy x squared. We see plus sign, we copy plus sign. Y squared, when we see y, we do not copy y. Instead, we are going to use x plus 4. Because y and x plus 4 is the same, right? So we could replace y with x plus 4 when we substitute x plus 4 for y. And copy equal sign, copy 10. And after this step, we have no y in the equation. We only have x. Then we can solve for x. All right, so x squared. I'm going to use a formula to expand this expression. The formula I'm using is this formula. Square of a plus b is a squared plus 2ab plus b squared. If you are not comfortable using this formula, you are welcome to use a FOIL. X plus 4 to the power of 2 is just x plus 4 times x plus 4. Yeah, whatever the method works for you, you can do that. I use the formula because it's faster, right? X squared plus ax plus 16. So I have x squared plus ax plus 16 equals 10. And x squared combined together, 2x squared, right? And then plus 8x plus 16 equals 10. Minus 10 from each side. I like to have this imaginary line in the middle. Separate left side and right side of the equation. And we would have 2x squared plus 8x plus 6. 16 minus 10 is 6 equals 0. Right hand side, 10 minus 10 is 0. And I notice this equation is quadratic. And we are able to get rid of a factor 2. So I divide all the 4 terms in the equation, including the 0 on the right side, by 2. Then we would have x squared plus 8 over 2 is 4. Half of 8 is 4. Plus half of 6 is 3 equals 0, right? And then this one is easy to factor. It's easy to factor. The left side can be factored as x plus 1 and x plus 3 because 1 and 3 multiply to 3 add up to 4. All right, right side is 0, left side is parentheses times parentheses. And in each parentheses, we have a variable x plus a number. The solution is going to be the opposites of the two numbers in red. Opposite of positive 1 is negative 1. Opposite of positive 3 is negative 3. So now we have values for x. We found the values for x. And not done yet. Now we find the value for y. As the first value, x assumed is negative 3. As x equals negative 3, we plug x equals negative 3 into equation 1, right? It's going to be very convenient. Equation 1, in equation 1, variable y is already in terms of x. So if we plug in x equals negative 3, here, replace x with negative 3. Negative 3 plus 4 is 1. We get the corresponding y value is 1. So when x assumes negative 3, corresponding y value is 1. We found the one solution. Another solution, as x equals, oh, I did negative 3 first. Yeah, negative 1, it really doesn't matter. We plug x equals negative 1 into equation 1, which is y equals x plus 4, right? Yeah. So when x equals negative 1 plus 4 is positive 3. That means when x assumes negative 1, y value is the corresponding y value. Variable y assumes 3. And that's another solution. Two solutions. Because this is a circle. Second equation is a circle. The second equation is a circle. The first equation is a straight line, goes up. Yeah. At most, they have two solutions. Not possible to have more than two. All right, we covered both methods, addition method and substitution method. Do you guys have any questions about this section, solving nonlinear systems?
No, you explained it really well.
Okay, thank you. You're welcome to use the graphing calculator in the system. It does help you to see the picture, to see how many solutions you end up with, right? Yeah, I don't mind because as I see, it doesn't help you all the questions. Some of them, yes, you can just directly find the answers from the graph, but some other problems you really have to use the algebraic method, either substitution or addition method to get the solutions. So now I don't have to worry about that. We right now is 10:08, and we are going to start a review. Okay, I'm going to get the review. Unit 2 test study guide. I have it posted in Blackboard already. And stop share that and then share the study guide here. This time I have one question in one page. The first question, perform the indicated operations and simplify. Give your answer in standard form. Okay, so the question has two parts. First part, we need to add two complex numbers. Second part, we need to subtract two complex numbers. I would say very easy, okay? Let's do that together. Now hide the floating meeting controls. Part one, we are adding two complex numbers, 10 minus 22i. Both of the two complex numbers are in the standard form. And the second complex number is 8 plus 25i. We actually could add two complex numbers vertically. If you like it, we can add them vertically. So align the real part and the imaginary part and the imaginary unit. Because both of the two complex numbers are already in the standard form, a plus bi, right? Just align them like that. Then we vertically add the corresponding parts. 10 plus 8, 18. Negative 22 plus 25. I don't know if anybody have trouble to handle addition and subtraction of numbers with a sign. You can try casino method. Yeah. So we are adding negative 22 and a positive 25, right? Well, you can use a calculator, but you can also use the casino method to make sense of the process. Let's say you play two games in the casino. The first game you lost $22. So your profit is a negative 22. If you lost, the profit is negative. If you won, the profit is positive, right? And the second game you play, you won $25. Okay, you only do two games. First game you lost $22. Second game you lose second game you won $25. Don't you end up with $3 profit? So it's 3, right? And then bring down I. And just like that. So when you add two complex numbers, just add their corresponding parts. Keep the imaginary unit. 10 plus 8, 18. Negative 22 plus 25, positive 3. Copy the imaginary unit. Put it behind the imaginary part. All right. Okay, I'm gonna give you a little time. You do number 2. You do part 2. Subtraction. Subtraction. Subtraction, probably horizontal method is better. Addition, vertical method definitely feel very comfortable. But for subtraction, you can use a horizontal method. I'll give you 2 minutes. Right now it's 13. I'll check with you at 15. Feel free to share your answer. What do you have, guys?
I got 2 minus 47i.
Awesome. Correct. Very good. It is 2 minus 47i. Very good. Let me show you the two methods, okay? We can use a vertical method if you want, but one step is a little bit uncomfortable. So 10 minus 22i minus 8 plus 25i. Okay, so the subtraction sign is not the negative sign of 8, is a subtraction sign, so I use different color. So use the vertical method to subtract. Our strategy is keep the top complex number and change. So the strategy is keep change, keep change. Keep the top complex number, change the subtraction to addition, and then change the complex number on the bottom to its opposite. The opposite of a is negative a. The opposite of 25 is negative 25. Copy I. And then we add 10 plus negative 8, 2. Negative 22 plus negative 25, negative 47. Yeah, some people prefer this method, even they do have to take care of keep change. They like adding things vertically because everything is very well aligned. Another method is the horizontal method. We have 10 minus 22i minus parentheses a plus 25i. We have two parentheses, right? We just need to get rid of the two parentheses and then combine like terms. The first parentheses has coefficient 1. The second parentheses has coefficient -1. Those are the two special cases when we apply the distributive property. When the coefficient of a parenthesis is a +1, we really could literally get rid of the parentheses. And that's the only case we can do so. When the coefficient is a +1, we really could get rid of the parentheses literally. 10 minus 22i. Because 1 times 10 is still 10. 1 times negative 22i is the same thing, right? And when the coefficient of a parenthesis is a -1, it's also a special case. What we need to do is remove the parentheses and then change whatever inside the parentheses to their opposites. Opposite of a, negative a. Opposite of 25i, negative 25i. And then we combine like terms. Now we do not have the walls, right? Walls are broken down. Then those four terms are free to be combined. 10, negative 8, 2. Negative 22i, negative 25i, negative 47i. Just treat I as a letter. If I is x, I believe you know how to do that, right? Combine like terms. It's in foundation. But I is imaginary unit, but you can treat it as a letter or variable. It's not a variable, but you can treat it like that to combine like terms. Very good. That's the first problem. Second problem. Express 7 plus rule -25 as a complex number in standard form. Complex number in standard form is a plus bi. Okay, let's do it. We have 7 plus rule -25. When we cover the first section of this unit, I give you one sentence. I wrote the sentence in red. That's something you need to include in your note and memorize, understand and memorize. I said, when you see a square root of a negative number, the first thing to do is to apply the formula. Write that expression in terms of I. Do you guys remember the formula? Square root of negative a, suppose a is positive, then negative a is negative, right? Square root of negative a is root ai. That's the formula I'm talking about. All right, so square root of negative 25. When you see square root of negative 25, right away, rewrite that expression as square root of 25i. And then simplify. Square root of 25, we all know square root of 25 is positive 5, right? 5i. And that's it. Very simple. The result is 7 plus 5i, and it is in a standard form. Yeah, this problem is just to test one formula. How do you rewrite a square root of a negative number in terms of I? This is the formula. Okay. Number 3. Yeah, I have the page number here. So page 3, we have question number 3. This way is better. We have enough space. This is a word problem, application problem. I think this is belong to 2.5, section 2.5, application of system. A movie theater has a seating capacity of 339. The theater charges $5 for children, $7 for students, $12 for adults. There are half as many adults as there are children. Okay, children. Yeah, why don't I just say the number of children is twice of the number of adults, right? That would no confusion. So I think this means the number of children is more than number of adults. There are half as many adults as there are children. Yeah, more children. If the total ticket sales was $2,464, how many children, students, and adults attended? We solved a similar problem. Yeah, this is the second time we see this type of problem. Okay, we are looking for X, Y, Z. Use X to represent the number of children who attended the theater. Y represent the number of students. Z represent the number of adults who attended the theater. All right. Capacity. We assume on that day the capacity was met. X plus Y plus Z equals 339. That's the first equation. We have 3 variables. We need 3 equations. Second equation, we can use this piece of information. There are half as many adults as there are children. So number of children is X, is twice of number of adults, Z. Children X, adults Z, X equals to Z. Do you agree, Michael?
Yes.
It means children is twice number of the adults, right? Okay, that's equation 2. Equation 3, we can use the price and the revenue on that day. So they charge $5 for children, $5 for 1 children. So if you have one child and the income from children is $5. If you have 2 children times 2, 3 children times 3, 10 children times 10. Now we have X children, so times X, okay? So $5 times X, $5 times X, so we have 5X. 5X would represent the income, the revenue from charging the children who attended the event, the theater. Same idea. They charge $7 for students. So 7Y would represent the revenue the theater collected from the students who attended. And similarly, they charge adults $12. So 12Z. Yeah, I want to align the equal sign. Let's see if I can do that. 12Z is the income from the adults. Together, okay, together on that day, they made the revenue was $2,464. That's equation 3. Here we go. We have the system. That system model the situation in the problem. And the rest of the the rest of the work is to solve the system, right? Let me give you 3 minutes. Okay, let me give you how about 2 minutes? At least to get yourself started. For unit 2 test, you have 80 minutes. You have 20 questions. So each question, no more than 4 minutes, right? Let me give you 2 minutes. Right now it's 25. I'll check on you in 27. A substitution method would be a good method because of this equation, right? Variable x is already written in terms of z. When you get a system, do not rush. You're gonna find a strategy, find a pathway. One more minute. Your method might be different from mine. It's totally fine. But it is very convenient to just apply the substitution method. You want to work this problem together? So in equation 2, variable x already is in terms of z. So we can just substitute 2z for x. And that's how do we eliminate the x in the system. So we're going to plug in x equals 2z in both equation 1 and equation 3. So equation 1 is x plus y plus z equals 339, right? And instead of write x, you use 2z to replace x. And you don't have z anymore. You don't have x anymore, I'm sorry. You don't have x anymore. Same idea, you plug x equals 2z into number 3. So instead of 5x, you have 5 times 2z, because 2z is x. And after this, you can see in equation 3, we do not have x either, right? Yeah, let's simplify a little bit. We successfully got rid of variable x just by using the substitution method. Equation 1, we combine like term 2z and another z, 3z. So we have y plus 3z equals 339. That's equation 1. After simplify. Let's simplify equation 3. 5 times 2z, that is 10z, okay? 5 times 2, 10, 10z. We have a 12z here. 10z plus 12z, that is 22z. 22z, yeah, 10 plus 12. And we have 7y here. 7y plus 22z equals 2,464. That's equation 3 after simplify. And then what do? We can also use the substitution method, but I'm going to use addition method in the next step to eliminate y. I'm going to eliminate the y. I'm going to multiply equation 1 by 7, negative 7, sorry. I'm going to multiply equation 1 by -7. Okay, equation 1 is y plus 3z equals 339. It's pretty simple. It's just 339 is a little bit bigger. But equation 3 is even has a bigger numbers. So equation 1 times -7, be careful with the sign. We have -7y minus 21z equals 339 times -7, right? Now let me see what is 339 times -7. 339 times 7. 2373. 2373. -2373. Right? That's the right side. -2373. Not too bad. Okay, let me double check. Equation 1. You see, I can use the color scheme yellow. Equation 1 is yellow. And now what happened is I multiply the yellow equation, all the 3 terms by -7. All right, that's how we have this equation. We can call the equation 3. It's just the modification of equation 1. And then put it together with we already have equation 3. You can do this as equation 4. And put it together with equation 3. Equation 3, 7y plus 22z equals 2464. Equation 3. And you will see equations 3 and equation 4. In those two equations, variable y has opposite coefficients. So if we add them together, add 4 and 3 together, -7y, you add them together, -3y, +3y cancel, right? And then -21z, +22z, add together just a z, very convenient. And on the right side, we just need to use a calculator. Use 2464 minus 2373. Okay, 91. Okay, z is 91. Z is 91. Okay, now we have the value for z. We can go back original equation 2 to find the value for x, right? Yeah, go back to equation 2 here. Z, we got a 91. Then x is twice of z, would be 182, right? Yeah, so now we have x and z found. X is 182. Z is 91. Now we only have variable y to solve for. And we are going to plug x equals 182 and z equals 91 into equation 1. Equation 1 is very simple, has a y in it, right? Equation 1 is x plus y plus z equals 339. Together, the total number of the attendees is fill the capacity 339. X is 182. Copy y. Z is 91 equals 339. And 182 plus 91 gives us 273. Yeah, equals 339. And then we minus 273 from each side. I'm doing on the right bottom right corner. And they cancel, we have a y equals 66 people. 66 people. Y is 66. And I would spend a little bit of time to double check, but I would not plug those 3 numbers into the system to check. I would plug the 3 numbers into the original sentences to check. All right. Together, let's see, 182, 66, 91. They do add up to, this is a 261 is 9. A and 9 is 17. 17 plus 6 is 23. So 33, 339. Yeah, total number, the sum of the three numbers is 339, that match. And the number of children is twice of number of adults, that match. And then for the income, you probably need to do some calculation here. I believe this is the correct answer, okay? Yeah, you can just quickly figure out how much money from children, how much money. You just need to type this number, multiply this number by children charge $5, and students charge $7, adults charge $12, and you add them together to see if you have 2,464. I believe the number match. So that's the answer. All right. So that's problem number 3. Problem number 3. Let's continue. It is time consuming. I do agree it. So when you take the exam, if one question is challenging, maybe you can skip it temporarily, right? To work on other easier problems that you know, and then you go back to that problem. And this is just one problem after all, just one problem. Question number 4. Question number 4 is about the multiplication of two complex numbers. Okay, we can use the FOIL, we can use the box method. I'm gonna give you 2 minutes. It's 36. I'll check with you in 2 minutes. Whatever method you prefer, and then write an answer in the format A plus BI in the standard form. We have a multiplication of two complex numbers, -1 minus 2i times -1 minus 4i. -1 minus 2i, -1 minus 4i. One more minute. Feel free to share your answer. Make sure you double check your answer before you share it. What do you have, everybody?
I got -7 plus 6i.
-7 plus 6i. Let me check.
That's what I also got.
Correct. Very good. Okay. So for this specific problem, I don't really want to confuse you because the actual problem on the exam might not be like this. But for this specific problem, because everybody has a negative sign, you see that? -1, -2i, -1, -4i. Because all the 4 parts have -1, we can get rid of them. 1 plus 2i, 1 plus 4i. Yeah, as I said, I don't want to confuse you because the two complex numbers in the actual exam might not be like this. But again, for this specific problem, it's really annoying just to carry the negative sign all the time, right? So we could get rid of it. The reason is because the first complex number can be written as the opposite of 1 plus 2i. And the second complex number can be written as negative of 1 plus 4i. And when we multiply them together, this negative sign and this negative sign cancel. Negative 1 times negative 1 is positive, right? So that's why we can do this. For this specific problem is convenient, is a good strategy, good step. But again, you might not need this in the actual problem in the exam. Okay, so let's use the box method. If you like to use the box method, this is how we do it. 1 plus 2i here, 1 plus 4i here. And we're multiplying, right? 1 times 1, 1 times 4i, 1 times 2i, 2i times 4i, 2 times 4, 8. I times I squared. I squared is negative 1, so negative 8. And remember this? Not cross multiply, okay? I didn't mean that. Why same color? Same color can be combined. Yeah, same color can be combined. Negative 1, positive 1, negative 8, negative 7. 4i, 2i, 6i. So same with your guys' answer, right? Or we can use a FOIL if you like. But be careful when you use a FOIL. I always set up the structure first. 8 parentheses, 4 sets. Add the 4 sets together. FOIL F, first times first plus, outside times outside plus, inside times inside plus last times last, right? And the first 1 1, outside 1 4i, inside 2i 1, last 2i 4i. 1 times 1 is 1, 1 times 4i is 4i, 1 times 2i is 2i, 4 times 2 is 8, I times I is negative 1, right? So you can combine like terms. 1 a times negative 1 is negative a plus 4i plus 2i. Combine like terms, we have negative 7 plus 6i. Now, again, actual problem, you might have to handle the negative sign. Yeah, maybe not all the 4 parts have a negative sign. So be very careful. Practice. Those are basic problem. You should not lose a point on it. All right, this is number 4. Let's keep going. Number 5. This is a solved system. Okay. Linear system. Both equations in the system are straight lines. I give you 2 minutes. I give you 2 minutes. Solve the system. I actually would rewrite the 2 equations in a slope-intercept form to help me understand the relationship of the 2 straight lines first. Okay, I got my answer. When we solve a system of linear equations, when the 2 equations in the system, they are just 2 straight lines, I would spend time, I recommend you do the same, spend time to rewrite the 2 equations in the slope-intercept form if they are not in the slope-intercept form yet. As you can see, the first equation after I rewriting the equation, I move negative 2x to the right. I have a y equals a positive 2x plus 6, right? Slope is 2. Slope is 2. Y-intercept is 0,6. The second equation, yeah, I have the work here. Yeah, I can do it again. So the second equation, let's simplify the second equation and then rewrite the second equation in the slope-intercept form. Negative 4y equals negative 22 minus 8x. Do you notice in this equation, we have 3 terms. All the 3 terms are negative. When this happens, you can just get rid of the negative signs for all of them, okay? Just apply the same treatment to everybody. Everybody right now is negative. We just get rid of the negative sign for all of them. So we have 4y positive equals 8x positive. I'll switch the order, plus 22, right? We want to rewrite the equation in the slope-intercept form. So we have to isolate y on the left side. So we need to get rid of 4. Divide by 4, divide by 4, divide by 4. 4 over 4 is 1. We have a y equals a over 4 is 2. 2x plus 22 over 4 is 11 over 2. So the second equation, after we rewrite the equation in a slope-intercept form, we have a y equals 2x plus 11 over 2. Look at the two equations. They have the same slopes. They have the same slopes, but different y-intercepts. That means the two equations are not overlapping, coinciding. They are parallel. Do you still remember the 3 cases? 3 cases for a linear system? 3 cases. The first case, the 2 straight lines cross. Unique solution. The solution is the intersection. Second case, the 2 straight lines are parallel, but they are 2 different straight lines. The third case, the 2 equations are the same equation. Yeah, they have the same slope, also the same y-intercept. They overlapping, coinciding. So infinitely many solution. One solution, case 1. No solution, case 2. Infinitely many solutions, case 3. Our problem, this problem, is case 2. The 2 equations, the 2 straight lines are parallel. No solution. We should choose this one. For the problem in the test, in the actual test, I'm not sure. You have to figure it out. How do you figure it out? You rewrite the 2 equations in the slope-intercept form. Slope-intercept form again, y equals mx plus b. If the 2 equations have different slopes, you are expecting to have one solution and figure out the coordinates of the one solution. If the 2 equations have the same slope but different y-intercepts, like what we have right now here, then no solution. If the 2 equations, after we simplify and in the slope-intercept form, they look exactly the same, they are the same equation, then you choose infinitely many solution. All right? Yeah. What case? What do we have in the exam? I'm not sure. You have to figure out. We have 2 minutes. Let's see what's the next problem. Division. Can we leave this problem next time? Division of a complex number. So we covered 5 problems. Next time we have 15 problems. We can slow down a little bit. Right? Any questions, guys?
Yeah, so when will the exam be open?
When will the exam be open?
Yeah.
I believe it's open right now, isn't it? It has a due date.
Oh, okay.
Yeah. So you should receive an email from the testing center and tell you the time window. The time window, what I said is probably from Thursday. Yeah, not today. I believe you really want to take the exam today, and I think they would let you because I already sent out the paperwork. But we are not finishing. Yeah, we are not finished the review yet.
Just asking, so.
Yeah.
I don't know how to schedule.
As early as Thursday, I believe. And until I have to look at is in Blackboard. Is in Blackboard. Feel free to email me if you have any questions. I'll see you on Thursday. Bye-bye.
I do have a question.
Yes, please.
The last one that we just worked, could you scroll back up to it so I could explain my thought? I saw where you put y equals 2x plus 11 over 2.
Mhm.
And then the one that you have solved on top of that, y equals 2x plus 6. Wouldn't we just leave that as the provided first one? And then just plug in the y that we found into that equation? Is that another way?
Then tell me what you have. You're gonna have a contradiction.
Oh, I didn't solve it. I just had the idea.
Oh, the idea is
didn't-
to, if you use equation 1 to minus equation 2, let me know if I understand you correctly. So this part is the same. This part is the same, right? If we use equation 1 to minus equation 2, we would have here's 0, left side 0, right side 6 minus 11 over 2. It's half. Isn't this a contradiction?
That's not the equation I meant. I meant the negative 2x plus y equals 6. That first would be able to solve the y from the 2x into there.
So why slope-intercepted form? In the slope-intercepted form, variable y is isolated on the right, on the left side. So negative 2x plus y equals 6. To rewrite this equation in the slope-intercepted form, we don't want this term on the left side. We want it on the right side. To do that, we can plus 2x to both sides, right? And they cancel. So we have a y equals 2x plus 6. Does that help?
Can I come in, Professor?
Did I hold on? Did I answer your question, Eliza?
Yeah.
Yeah. When you also, I introduced my side and sign method. We can move those terms whatever we want. Just remember, when you move a term from left side to the right side, you have to switch the sign in front of it at the same time. So we can just, this is the term, right? We can just move that term to the right. But remember, change the sign in front of it, positive. It was negative on the left side. It has to be positive on the right side. So it becomes positive on the right side. Yeah, that's about algebra. Okay. Esther, what's your question?
Yeah, I was trying to buttress what Eliza question was, because that was the same thing I did. I plugged 2x plus 6 for y beside the minus 4. So when I finished doing my calculation, well, it still fall back to what you said. I got minus 2 is equals to 0, which means there is a contradiction.
Yes, if you apply the substitution method,
Yes.
you will have a contradiction, like a 0 equals a non-zero number. And a contradiction also can tell you the system has no solution. But yeah, another way to actually know that is to just rewrite both equations in a slope-intercepted form. And you can just tell, you know what? There's a calculator here. Yeah, if you see a problem on a test, enter the two equations in a calculator, you will see which case the problem belongs to, right? If you see this, okay, you need to find that unique solution. If you see the two straight lines parallel, just choose no solution. If you see the two equations actually are the same equation, you only see one straight line, then infinite many solution. Okay, use calculator. I don't mind you do, take advantage of whatever you have during the test. That will help. Yeah. All right, guys.
Oh, thank you.
No problem. I'll see you on Thursday.
Thank you.
See you on Thursday.
See ya. Bye bye. Oh, I see the chat here. I missed it.
Goodbye.
See
Thank
ya.
you.
Bye bye. Where do I find the chat? Show chat previews. Oh, it's here. Would